myself, Dr. Balasaheb Wankhande, Walchand College of Engineering, Sangli. Today I am going to talk about waves and its types. The objectives of this topic: the student will be able to define the wave, define the types of wave, and understand the parts of wave. The first part is introduction. What is wave or define wave? Wave is an oscillatory disturbance traveling through a medium without change of form. Waves carries energy from one place to another place. Waves does not carry matter with it. It just moves the matter as it is go through it. After that, the types of waves. There are two types of waves. One is mechanical waves and second one is electromagnetic wave. For the propagation of mechanical waves, material medium is required. Means energy transfer through material medium. A medium is the substance through which a wave can travel. Example: air, water, particles, strings, solid, liquid, and gaseous mediums. And second type is electromagnetic waves. For the propagation of these waves, material medium is not required. Means energy transfer without material medium, because these waves, electromagnetic waves, travels through the vacuum. They do not need medium, but they can go through matter, means medium, such as air, water, glass, etc. Then the types of mechanical waves. Here is also there are two types of mechanical waves. One is transverse and second one is longitudinal waves. First one is transverse wave. These waves are in which particle vibrates perpendicularly to the direction of propagation of the wave. Transverse waves consists of crusts and troughs alternately. Waves, water waves, waves on rope, electromagnetic waves. These are the best examples of transverse waves. Then parts of transverse wave. Here, this highest point or maximum point of wave is called as crust. That is nothing but maximum displacement of particle from its mean position. And here it shows crust of transverse waves. Then the valley between two waves, that is called as trough. Trough is the valley between two waves, that is nothing but it is the lowest point. Means upper point is called as crust and lowest point is called as trough. Then the third part of transverse wave is wavelength. It is the distance. Here in this figure there are two crusts. This is one and this is second. In between these two successive crusts, the particular length is called as wavelength. The wavelength is the horizontal distance, either distance between crusts or troughs of two consecutive waves, or wavelength is the distance between two successive particles which are in same phase. Next part is amplitude. Amplitude is the peak value of the wave. maximum displacement of particle from the mean position. This is the mean position, and from this mean position this is the maximum displacement, lower maximum point, and this is upper maximum point. The maximum displacement is called as amplitude. Here the ocean wave is an example of mechanical transverse wave. Here point A is crust, B is also crust, and in between these 2 points, distance between these 2 points is called as wavelength. This is the trough, and this is the crust, and this is the trough, and this is the wave height. Also it is called as amplitude, which is measured in meter. Then the next type is first type is transverse wave, and second one is longitudinal, or also it is called as compression wave. These are the waves in which particles vibrates back and forth along the path that waves moves. These waves are also called as compression waves. Longitudinal waves consist of compressions and rarefactions. Waves on spring or sound waves are the best example of longitudinal waves. Then the parts of longitudinal waves. Longitudinal wave consists of compression and rarefaction. Here, compression is the part of longitudinal wave where particles are crowded, and here particles are separated. This part is called as rarefaction. Means rarefaction is the part of longitudinal wave where the particles are separated apart. Wavelength. Wavelength is the distance between 2 successive compressions or 2 successive rarefactions. It is called as wavelength of longitudinal wave. Then electromagnetic waves. Electromagnetic waves are the light waves. For the propagation of light waves, material medium is not required because they are transparent, because they are traveling through the vacuum. Examples of electromagnetic waves: radiations, TV and radio waves, microwaves, X-rays, visible light, energy from sun, lasers. These are the examples of electromagnetic waves. Simply, light waves. Electromagnetic waves are considered transverse waves because they have similar characteristics, and therefore they have the same parts, crusts and troughs. Electromagnetic spectrum. The electromagnetic spectrum illustrates the range of wavelengths and frequencies of electromagnetic waves. Here in this spectrum, in this side means left side longer wavelengths and right side shorter wavelengths. Means from left to right frequencies increases. Means here at the right side frequency is higher. Here this spectrum consists of gamma rays. Gamma rays are the high frequency, very short wavelengths. After that X-rays. X-rays are 2 types, hard X-rays and soft X-rays. Then again frequency decreases here, ultraviolet, visible, infrared, microwaves, and finally radio waves. Radio waves are the longest wavelength waves. These all waves are called light waves. Thank you.